This is in section 4.1 in our book. We're skipping from chapter 1 to chapter 4 for right now. You should have a handout to write all of these notes on to make things go a little quicker. So first we're going to go over some vocabulary. Today we're talking about inequalities. Some of this will be review from last year because you have learned about inequalities before. So our first vocab word, inequality. The definition of that is any sentence containing a less than symbol, greater than, less than or equal to, greater than or equal to, or a not equal to sign. An inequality is any sentence containing one of those things. So the solution to an inequality is any value for the variable that makes an inequality true. So any number you can plug in for your variable that makes it work, those are all solutions. So you usually will have a lot of solutions to your inequality. Your solution set is when you put all of those solutions together. It's the set of all solutions. So solutions are anything that work. The solution set is when you state all of them at once. So for example, a really simple one here, x is less than 9. That's what this one says. You guys can remember kind of that the alligator's eating the smaller one, so x is smaller here. So some of the solutions to this, you cannot write them all. There's infinite solutions to this. But some of the solutions include 8.9, 8, -1. Anything less than 9, those work in that case. Our solution set is, well, any number less than 9. That's the whole solution set. It's all of them. If you wanted to write that in set builder notation, which we've learned about, you would just write it like this. Any number x such that x is less than 9. That's it. So we're going to do an example next. For example, determine whether the given number is a solution of the inequality. So our first problem here says x plus 3 is less than 6, and we want to test if 5 is a solution. So all we do to test that is we substitute 5 in for x. So instead of x plus 3, I'm going to write 5 plus 3 is less than 6, and then we just see if it's true or not. So 5 plus 3 is 8, and I can go ahead and write that out. 8 is less than 6. So then you just think about it. Well, is that true? Is 8 smaller than 6? No, that's not true. So our answer here is no. 5 is not a solution to that inequality because it does not work. Let's try this other one. So this other problem wants us to see if -1 is a solution to the inequality. -3 is greater than -9 minus 2x. So I'm going to rewrite this, but I'm going to substitute in -1 for my x value. Let's go ahead and simplify that right side. So I'm going to go ahead and do -2 times -1. That's +2. So I've got -9 plus 2. And then right here, -9 plus 2 is -7. So this is saying -3 is greater than -7. Well, that's true. -3 is greater than -7. That's true. So our answer to this is yes. -1 is a solution to that inequality. So those problems are not too bad. Now we're going to review graphing inequalities. This is something we talked about a lot last year in 8th grade math, and you probably did it before that too. So in these little boxes right here, I want you to fill in that if you have a less than sign or a greater than sign, on your graph, you're going to use an open circle. Now, I also want you to write this. This is kind of weird. Or I don't want you guys to do this, but your book is going to use a parenthesis in either direction to show it. I don't like that. I'll show you what I mean, what they mean by that, but just know that you can use a parenthesis instead of an open circle. When you check your answers, that's how your book will look. So if it's greater than or less than, you use an open circle on your graph. If it is less than or equal to, or greater than or equal to, you're going to use a closed circle on your graph. Okay, so this one is an open circle. If you have the little or equal to thing under it, it's a closed circle. And in your book, they're going to use a bracket. I'll show you what that looks like. So for example, we're going to graph x is less than 3. So if you had me for class last year, you know that, maybe you remember that my rule for graphing an inequality is that you need to put at least 2 integers on each side of your number. So we're going to show everything that is less than 3. So I want you to put 4 and 5 and 2 and 1. You need to have at least 2 numbers on either side of that 3. That's kind of my rule to make sure your line's big enough. You don't have to go any bigger unless you want to. So if we look at our inequality here, x is less than 3. There's no little or equal to symbol under that. It's just less than. So we're going to use an open circle here. So I'm going to put an open circle on my 3. Now I want to show everything that's less than 3. My mystery number x is smaller than 3. So I want all the things that are smaller than 3 shaded. So here's where you have a choice. You can either use a highlighter, and you can highlight that line. Whoops, supposed to be a highlighter here. You can highlight that line. Just make sure you highlight the arrow. That's really important. I need to know that you're going all the way to negative infinity. If you don't want to use an arrow, you can use your pencil. You just need to go above the line, straight up, straight over, and then draw an arrow. Go all the way over to the end of your graph and draw an arrow. I'm going to be really picky about this. Okay, I want these to be nice and neat. I should really be able to clearly see what it says. Don't rush through drawing these. Draw them nice and neat for me. Now, in your book, I want you to show you what it's going to look like if you check your answer for that same problem. So you would have your number line. And then instead of the open circle, they're going to do parentheses. So they're going to do a parentheses on the 3. And I think in your book they shade it. So then you would see shading this way. And they'll have a parentheses. That just means open circle. And if it's a bracket, that just means there's a closed circle there. It's kind of weird. Honestly, I've never seen that before in this book. It's kind of strange, but good to know, I guess. All right, so now we're going to fill out that big table that you guys see on there. All right, so we're going to talk about 3 different notations we can use to write our inequalities. You guys are already familiar with 2 of these. You're familiar with set builder notation and the graphing. We're going to talk about interval notation, which will be new. So we're going to go through a bunch of examples here. The first example I want to use is this. Any number x such that x is greater than 2 and less than 5. So it's kind of between 2 and 5, but it doesn't include 2 or 5. Hopefully we already know what that means. To write this in interval notation, what you're going to do is, since x is between 2 and 5, you just write 2 comma 5. And since it's just less than or just greater than, there's no little or equal to thing under it, just less than, just greater than, you're going to put a parenthesis on each side. That means that it goes right up to 2, but it doesn't hit 2, and it goes right up to 5, but it doesn't hit 5. Those parentheses mean that it doesn't hit it. And then to graph that, I'm just going to make these graphs really simple. I expect you guys to have more numbers on your graph. I'm just going to put 2 and 5 on here. Just when you do your homework and everything, put more numbers on your graph. So since x is between those, but it does not equal either of those 2 things, we're going to do open circles on each of those. X is bigger than 2, but less than 5. So we need to shade everything that's greater than 2. But less than 5, so right in the middle there. That's what our graph would look like. All right, let's try another one. So now we're going to look at the inequality where x is between 2 and 5, but it could equal either of those numbers. So we're going to look at all numbers x such that x is greater than or equal to 2, and it's less than or equal to 5. So now since x can reach those two numbers, we're not going to use parentheses anymore. We're going to do the same thing, x is between 2 and 5, but we're going to put a bracket on each of them. Be really nice and neat with your brackets, because if I can't tell on a test or something, I'm going to have to mark it wrong. So make very clear brackets there. This means x is anything between 2 and 5, and it goes up and hits 2 and 5. It can be 2, and x can be 5. On our graph, since x can equal either of those two numbers, we're going to do a closed circle on those because of the little or equal to thing in our notation. X is anything between 2 and 5, including 2 and 5. And then we just go ahead and highlight everything in there. On this one, it's kind of hard to draw an arrow. You can't really do it. So if you don't have a highlighter, you can just really darken in your line right there, make it really clear. All right, let's look at another one. Now we're going to look at what if we only have one of the sides has an or equal to symbol. So let's say that x is a number such that x is greater than 2, but it's less than or equal to 5. So now we have one of the symbols has an or equal to thingy under it, and one of them doesn't. So the way we would write this is, well, since the 2 doesn't have the little or equal to thing, the 2 gets the parentheses next to it because it can't touch 2, can't reach it, it goes right up to it. But the 5, since it has a or equal to thing next to it, it gets a bracket. So you can have one parenthesis and one bracket. On our graph, we would have an open circle on the 2 because it can't touch 2, it just goes right up to it. Open circle on the 2, but a closed circle on the 5 because x can equal 5. And then go ahead and just like we've been doing, we shade in between there. All right, let's try another one. So this time we're going to do any number x such that, I'm just going to switch it this time. X is less than or equal to 2, or sorry, greater than or equal to 2, and less than 5. So now I just switch which one gets the little or equal to symbol. Now x can equal 2, but it can't equal 5. So it's pretty similar. Since x is greater than or equal to 2, I put a bracket on the 2. Since x goes right up to 5 but doesn't touch it, I put a parenthesis on the 5. On your graph, just the opposite of last time. X can equal 2, so we put a closed circle. X cannot equal 5, so we put an open circle there. And then we shade everything in between. Make sure when you shade, I can still tell if you have closed or open circles. Now we're going to do some different types, and I just realized that your table has one fewer spot than it needs, so we'll have to do one at the very bottom, but that's okay. All right, so we're going to do some that are a little bit different. Let's say x is not between two numbers. Let's just say that we have all numbers x such that x is greater than 2. That's it. All we know is it's not between 2 and 5 anymore. It's just anything greater than 2. I'm actually going to skip to the graph of this really quickly. So if x is greater than 2, we know how to graph that. You're going to have an open circle on the 2 because it cannot equal 2. And then we're going to shade everything greater than 2, including the arrow. Now that arrow is really important. That means that x goes up, 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 all the way past 2 forever and ever and ever and ever, never stops any number greater than 2. So the way we write this for our interval notation is we think about where it starts and where it ends. So x starts at 2. That's the lowest it can be is 2. And it can't touch 2, so we do a parentheses. Now this is where it gets tricky. The highest our x could be? Well, it goes up forever. So the highest it could be is infinity. So you get to write infinity and beyond. So then we have to think about, do we want a parentheses or bracket? Well, here's the thing. Infinity is not really one number, so you can't really go up and reach it. So infinity is always going to get a parentheses. So this is saying, hey, x is anything from 2 up to forever, to infinity. X is greater than 2. All right, let's do 3 more that are kind of similar to that. So let's do now, what if x is greater than or equal to 2? All numbers x such that x is greater than or equal to 2. So if we do that on our graph, since x can reach 2, we color that circle in. So x can be 2. It's also anything greater than 2. So we're going to highlight everything on the greater than side. Then our interval notation is going to look pretty similar. The only thing is that since x can reach 2, it can hit 2, we do a bracket at 2. And then it goes on forever. X is anything greater than 2, so it goes all the way up to infinity. And we do a parentheses because you can't hit infinity. All right, 2 more, and we're done with this table. So another thing I want to look at is less than in these cases. So what if I have all numbers x such that x is less than 2? If I'm going to graph that, I need an open circle on my 2 because x cannot reach 2. It just goes right up to it. It doesn't touch it. But since it's less than 2, we need to shade everything to the left, including the arrow. So now, when we're writing this in interval notation, we think about the lowest thing that x could be. Well, x is anything less than 2. Anything less. It goes down, 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 down forever and ever and ever, all the way to negative infinity. So if it keeps going down forever, the smallest thing it can be is negative infinity, and that gets a parentheses because infinity always gets a parentheses. And the highest 2 can be is 2, or sorry, the highest x can be is 2, and it cannot equal 2, so we put a parentheses there. All right, sorry about this. You're going to have to extend your graph, your table here by 1. The last thing I want to do is, what if it is, the last combination we have is x is anything less than or equal to 2. It's very similar to the last one, but now x can reach 2. So on our graph, we would want x to hit 2, so we want to put a closed circle there. And then we want anything less than that, so we're going to shade everything smaller. And then for our interval notation, it starts at negative infinity because x goes all the way down, 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 down. The highest x can be is 2. And since x hits 2, we put a bracket on the 2 to show that x can equal 2. All right, so let's try an example with this one. Here's an example. Graph y is less than 6 on the number line, and write the solution set using both set builder and interval notation. All right, so let's get our graph ready for this. Go ahead and put 6 in the middle. I like to have at least 2 numbers on either side of that if you're making your own graph. Since y is anything less than 6, but it cannot equal 6, we need to do an open circle on the 6. And then y is smaller, so we need to shade everything smaller than the 6. Remember, you can also do that arrow that goes up top, but you have to go straight up and straight over and put an arrow on the end. So now if we're going to write this in set builder notation, well, that one's really easy because they basically already gave it to us. We just have to add in the squigglies and everything. So we just say all numbers y, because we're using y in this case, such that y is less than 6. That's it. You basically just wrote exactly what they gave you there. Now for interval notation, this always seems to be the hardest part for students. Think about the lowest and highest it can be on this graph. The lowest, well, it goes on and on forever in the low direction. So the lowest it can be is negative infinity. Y goes up to 6, but it does not hit 6. It cannot equal 6. We put a parentheses on the 6. So I know that was a lot of notation. So now we're actually going to start some solving of inequalities here. All right, solving inequalities. So here's 2 tips. We did this last year, actually. Solve an inequality as you would an equation. You know, get all your x's on one side, get x by itself, blah, blah, blah. The only thing different is when you are multiplying or dividing by a negative number, you have to flip the inequality symbol. So if it says less than, you're going to flip it to be greater than. If it says less than or equal to, you're going to flip it to be greater than or equal to. Anytime you multiply or divide by a negative. So let's try some of these examples here. So we're going to solve and graph these. So you go ahead and I'm going to put a line through my inequality sign, just like I would do if it was an equal sign. Now here's our t. He wants to be all alone in his house, on his side of that fence. So we need to get rid of that plus 5, so we just subtract 5 from each side. And we are left with t not equals, we still have this greater than sign. And 1 minus 5 is negative 4. That's it. I'm just going to rewrite this so that line's not through it. T is greater than negative 4. That's my solution. We didn't multiply or divide by a negative, so we don't have to flip the sign. I'm just going to graph this really quickly here. So I put negative 4 in the middle, put 2 numbers greater and 2 numbers smaller. We need an open circle on our negative 4 because it's not or equal to. And since t is everything greater than negative 4, we need to shade everything in the greater than direction, including the arrow. That's it. All right, let's try a slightly more difficult example here. So we've got 4x minus 1 is greater than or equal to 5x minus 2. So just like in any other equation, I'm going to draw a line through my equal sign. I want to get all those x's on one side. I like my x's to be on the left, so it's up to you, but in this case it's good to make them go on the left because it kind of points out something important here. So we're going to subtract 5x from each side so that we don't have any more x's on this right side. We're left with 4x minus 5x, which is negative 1x. And then we still have the minus 1. We still have greater than or equal to because we didn't multiply or divide by a negative. All we did was subtract. And on this other side, all we have is negative 2 left so far. So now, just like any other one, we're trying to get this x by itself. We have a negative 1 being multiplied and a negative 1 that's, well, it's added, I guess. It's a 1 being subtracted or a negative 1 being added. We have to do that, undo that subtraction first. So we need to add 1 to each side. So we're left with negative 1x, still greater than or equal to negative 2 plus 1 is negative 1. So now, to get x by itself, I need to divide by negative 1 on each side. This is why I wanted to move all the x's to the left side, because now I'm dividing by a negative number. That means instead of x is greater than, I'm now going to flip that symbol. See how I flipped that symbol? From greater than to less than. And then negative 1 divided by negative 1 is positive 1. So our solution here is x is anything less than or equal to 1. We need to graph that. So I'm going to put 1 in the middle, put 2 numbers on either side of that 1. Since x can equal 1, I'm going to put a closed circle there. And it's anything less than or equal to 1. So I'm going to shade anything smaller than or equal to 1. One more example. All right, so here's what this one says. Let f of x equals negative 3 times the quantity x plus 8 minus 5x. That's f of x. F of x is just a fancy way of saying y. It's just like an equation. And then our other equation, we're going to call it g of x. G of x, that's how we read that, equals 4x minus 9. Find all x for which f of x is greater than g of x. So what this is saying is that we want to find when this equation is greater than this g of x equation right here. So let's just write that out. Negative 3 times x plus 8, all of that minus 5x. That's f of x right there. So this is f of x. I want to know when is that greater than g of x, which is 4x minus 9. So this is g of x right here. All I did was basically plug my two equations in right there and right there. Now we just solve it. Just like a normal equation, just make sure you flip your inequality sign if you multiply or divide by a negative. So right now I see some distributing that I need to do here. Let's go ahead and distribute this negative 3. So negative 3 times x is negative 3x. Negative 3 times 8 is negative 24. Now everything else is the same. All I did was distribute there. Now, I'm going to draw my line through my inequality symbol because I forgot to do that earlier. Now we can combine some like terms on one side of that fence or that line. We can combine negative 3x minus 5x. That's negative 8x. And then we have minus 24 is greater than 4x minus 9. I'm not flipping my inequality symbol because I haven't even done anything to both sides yet. All I do is combine my like terms. Now we want to get all of our x's on one side of this equation. I always like to move mine to the left, so I'm going to subtract 4x from each side. If you wanted to add 8x to each side, you could do that too if you wanted. So over here we've got negative 12x minus 24 is greater than negative 9 is what's left over here. Now we need to add 24 to each side. So we are left with negative 12x is greater than negative, oh, sorry, not negative 9 anymore, 15. We still haven't had to flip our sign. We haven't multiplied or divided by a negative at all. We've done some adding, some subtracting. But now, to get x by itself, we need to divide by negative 12 on each side. So we just divided by a negative. That means we are now going to have to switch that from a greater than to a less than symbol. So x is less than 15 over negative 12. And I do want you to simplify that fraction. We can divide each of those by 3. So 15 divided by 3 is 5, and 12 divided by 3 is 4. So we have x is less than negative 5/4. I'm not going to make you graph that one. All right, this was a long one, but hopefully you got all your notes. The homework is listed at the bottom of the handout. So go ahead, and if you guys have time, you can start working on that. If you didn't finish the video in class, finish it at home for homework. Thanks for watching.